Hey everyone, welcome to our YouTube channel, and in this video we are going to learn digital electronics topic NAND gate latch, also known as the SR latch, using a NAND gate. So in the next about 5 minutes to about, let us say, 10 minutes, we are going to finish off this topic in a way that you will understand everything related to the SR latch. So first of all, let me draw a very simple diagram of what basically is an SR latch using NAND gate all about. So for that, what I do is I first draw a NAND gate right here, giving it an invert operation, and just below it I draw another NAND gate. So we'll draw an AND gate followed by a bubble. So we'll give an input to the first NAND gate over here, and we'll give one input to the other NAND gate over here. Now what happens is we have an output in this terminal and an output from this terminal. So what happens is that from the both these outputs, we take one output as like this, and then what we do is that we feed this output in the input of the second latch. So let us say this is NAND gate number 1 and this is NAND gate number 2. So what will happen is, as far as the second input of these NAND gates is concerned, this will go and connect onto this one, and as far as this NAND gate is concerned, this will take its, let me jump the wire, and like this. So this basically is a very simple structure of a NAND gate latch, and this is also known as the SR latch. Now what basically is the SR latch, the full form, that we'll see in a moment from now. So one of the input here is taken as a set, and the second one here is taken as clear. Now in some cases what happens is this is also referred to as a reset counter. So basically when we talk about the SR latch, what we are referring to is S here refers to a set condition and R here refers to as a reset condition of the NAND gate latch. So this in a nutshell is about that. So now let us see basically what happens as far as the construction and the operation is concerned. So as far as the construction of this particular NAND gate latch is concerned, this shows the latch is constructed from NAND gates, and it is called a NAND gate latch or simply a NAND latch. Now as seen from the diagram, the two NAND gates are cross coupled. So this means the output of the one of the NAND gate is connected to the inputs of NAND 1, and the NAND gate latch two outputs are labeled as Q and Q bar. So this is Q and this is Q bar. Now under normal conditions, what will happen is that these outputs will always be the inverse or the complement of each other. So as you can see, we have taken Q here and Q bar over here. Now the latch has basically two inputs known as the set or the clear. Now the set input sets the Q output of the latch to 1, while the clear, this one here, sets the Q output to a 0 state. So basically there are two types of combinations which are kind of possible here. So let us go with the first one. So normally what happens is that the set and the clear inputs of the latch are resting in the high state. So which means that this output would be 1 and even this output would be 1 over here. Now whenever we want to change the latch outputs, one of the two inputs will be pulsed as low. So either it can be this one or this one. Now let us begin our study by showing that there are two equally likely output states when the first one, let us say, is set and clear. They both are equal to 1, that is, both are in the high state right now. So what will happen is that there is one possibility, which is that the values of Q and Q bar here will be 0 and 1. Now with Q equal to 0, the input to the NAND 2 are 0 and 1, which produces Q bar equal to 1. The 1 from Q bar, this one, causes NAND 1 to have 1 at both the inputs to produce output at 0. Thus we find that the low at the end NAND 1 output produces a high at the NAND 2, which in turn keeps the NAND 1 output low. Now as far as the truth table, let us say, is concerned, so if we have two inputs, let us say inputs, we'll make a table here, we'll term this as set, we will term this as clear, and right here in the table we have the output. So as far as the set and the clear inputs are concerned, if set is 1, clear is 1, the output that we get is technically about no change. Now as far as the second condition is concerned, if we have set as 0 and clear as 1, then the output would be 1. Moving ahead, if we take this as 1 and this as 0, the output in this case would be 0. And if we have a low state on set as well as the clear NAND gate, so basically what is happening is that this will result in Q and Q bar both resulting in a 1, which technically is an invalid condition over here. So this basically is known as a very simple approach to what an SR latch is technically all about. Now the action of clearing a flip-flop is called resetting. Now both these terms, that is clearing or resetting, are used interchangeably in the field of digital electronics. Thus a set clear latch can also be referred to as a set reset latch or simply the SR latch. So this basically is what is known. Now as far as the clearing the latch is concerned, now we will study what happens when the clear input is pulsed low while the set is kept high. So in that case what happens is that there is some basic change in this one. So prior to the application of the pulse, and now since Q is equal to 0 is already keeping the NAND 2 output high, the low pulse at the clear will not have any effect. When clear returns high, the latch outputs are usually they are still Q equal to 0 and Q bar equal to 1. Now as far as the setting of the latch is concerned, we have already mentioned that if set and clear both equal to 1, then there is technically no change in this one. So this in a nutshell is an SR latch. So I hope that this video was informative enough, and for more such videos don't forget to subscribe to our YouTube channel. Thank you so much for watching.